focus on a few physical properties that we need to talk about. Density is one of them. Most of you probably know the formula for density. Density equals the mass divided by the volume. And as long as we know 2 out of the 3, we can solve algebraically for the third. Usually the unit for density is a mass per volume. So 1 unit for mass is grams, and 1 unit for volume is centimeter cubed. As long as it's mass per volume, it can be anything. For example, you can have kilograms per meter cubed, or you can have centigram per milliliter. All 3 of those are acceptable. The most common that you'll see is going to be this one. Except for gases. Sometimes gases are written in a different unit, because if you wrote them in this value, you'd get a tiny, tiny decimal number. So what about some common densities? Let's take a look. We have a variety of densities up here. Let's point out a few things. Water, of course. Standard density for water is 1.0 grams per centimeter cubed. And a good rule of thumb that you probably have heard is anything with a density greater than 1 is typically going to sink in water, and anything with a density less than 1 is typically going to float. So you see wood here, a density of 0.85 grams per centimeter cubed. That's less than 1. Wood floats on water. Of course, we know air bubbles up through water. Look how tiny its density is. And you have something like gold with density of 19.3 grams per centimeter cubed. It certainly will sink in water. Then you have some that are very close to the density of water, although the tendency for these is just to mix and make a solution, but we'll get to that later on. And ice, unique thing about water is when it freezes, its solid state is less dense than its liquid state. That's unusual. So the solid state of water, ice, floats. So kind of interesting little thing about H2O. So let's say we're doing a problem and we are given a piece of aluminum and we put it in a 25 milliliter graduated cylinder and it contains 10.5 mils of water. So one of our volumes is 10.5. So how are we going to solve for it? Well, the water goes up to 13.5. So 13.5 milliliters. And it started at 10.5 milliliters. So the water rose 3 milliliters. So whatever water was displaced, and that's of course what it would be here, whatever water rose, it was displaced, that's the volume of the aluminum piece. So we have V, and we're asked to find the mass of it. We don't know the mass, so we do know the density. That's given right here. So D equals 2.7 grams per centimeter cubed, or gram per milliliter. And now we're going to set up our formula. And we need to rearrange it to solve for m. A couple ways to do this, of course, algebraically. You would want to get rid of the v's on both sides. Whatever you do to one side, you have to do the other. So it would be density times volume on the left, and mass would be left by itself. So to find mass, you multiply density times volume. There's another way that algebra teachers don't particularly care for. You set up a little triangle. D goes here, M goes there, V goes there. Then you cover up whatever you're solving for. So for cover up M, D and V are next to each other. So we know that means times. And if you were solving for V, M over D is how you'd solve for volume. And of course, D is M over V. But let's go ahead and solve it more algebraically. So M equals the density, 2.7 grams per milliliter, times the volume, 3.0 milliliters. We're going to cancel out our mils. And then what does that leave us with? That leaves us with grams. And all we have to do is multiply the 2.7 times the 3, and that gives us a value of 8.1. And we can't forget our unit. Our unit's grams. So that piece of aluminum was 8.1 grams. Pretty straightforward problem. Not anything too difficult. And you should know the formula for density, M over V, know what each of those variables represents, and be able to solve for any of the three variables. All right. So that's a little bit about density. And this was part 3. Part 4 about data analysis is coming up soon.